Okay, these are the notes for section 1.6 solving equations. You should have read section 1.6 already before doing these. Primarily what we're going to do is we're going to look at a few examples here. Solving equations is something you spend a lot of time on in your first algebra course. Just a reminder, when we're solving an equation, any sort of a linear equation meaning that it forms a line if we were to graph it, when we're solving that, what we're going to do is we're going to work our way backwards through our order of operations. Okay? So when we're solving an equation, really what we're doing is we're undoing what has been done to the independent variable. So let's take a look at this first example. It says, in the board game Monopoly, you purchase 4 houses and a hotel on Illinois Avenue for a one-time cost of $750. You will earn rent of $1,100 each time another player lands on the property. If I players land on Illinois Avenue, then your profit is f of I is equal to 1,100I minus 750. What is your profit after one player lands on Illinois Avenue? Well, really what we're doing here is we're evaluating that function when I is 1. So I'm going to put 1 in for I. So f of 1 is 1,100 times 1 minus 750, which would be $350. So that means that the profit would be $350. Okay. Part B says how many players must land at Illinois Avenue so that the profit is at least $15,000. So now what I'm doing is I'm solving this equation, this function, for when the function's value is 15,000. Okay? So I'm plugging 15,000 in for f of I. So I have 15,000 is equal to 1,100I minus 750, and now I'm going to go through and solve that. So I have to, what I'm trying to do is I'm trying to get I by itself. So I'm going to undo what's been done to I. Well, if you think about what's been done to I, we're multiplying it by 1,100, and we're subtracting 750. So when I solve the equation, I said I'm going to go backwards through the order of operations. So the last thing in my order of operations is addition or subtraction. So the first thing that I'm going to undo is addition or subtraction. So in this case, I'm going to undo the minus 750 by adding 750 to both sides, which gives me this. And then I'm going to undo the multiplication by dividing both sides by 1,100. That gives me a little over 14 times. But it wants to know in such a way that your profit is at least 15,000. Therefore, the number of times would have to be 15 that a person would land on that. Okay, another review topic from Algebra 1 is the idea of the distributive property. By definition, the distributive property just says for all real numbers a, b, and c, if I take c times the quantity a plus b being in parentheses, then that's the same as c times a plus c times b. We distribute the c to both or all of the values that are being added or subtracted inside of parentheses. That's what the distributive property tells us. Here's an example of the distributive property. Okay, notice how I've multiplied -3 times each of the terms that is inside the parentheses. Okay, so let's take a look at number 2, where we have to utilize the distributive property in part to solve this. It says, suppose you just received $50,000 inheritance. At first, you decide to invest some of the money in a certificate of deposit account that earns 6%. The rest of the money is in a savings account that earns 4%. If X dollars are invested at 6%, then E of X is equal to 0.06X plus 0.04 times 50,000 minus X would give you the interest earned in 1 year. If you want to earn $2,500 in the first year, how much money should be placed in each account? Okay. So what I'm going to do is I'm going to set, because I want my interest to be equal to, after 1 year, the value, in other words, the value of e to x, to be equal to 2,500. I'm going to set 2,500. I'm going to replace e of x with 2,500. Okay. Now I'm going to solve this. Well, the first thing I'm going to do in my solving process is I'm going to use that distributive property, because if I distribute that through, that will allow me to combine my like terms of x's, my 0.06x and my negative 0.04x, to get this. Now I can go through and think about, okay, my order of operations. Well, the last thing that's being done to x is I'm adding 2,000. So the first thing I'm going to undo is I'm going to subtract 2,000. So right here I'm subtracting 2,000 from both sides. Then I'm dividing both sides by 0.02 to get my value of x, which would be 25,000. So in other words, they would have to put $25,000 into the account that earns 6%. Okay, another method that we use to help us in solving equations is the idea of clearing fractions. This is something that we use for simplicity. It's not something that we have to do, but we can do it by multiplying both sides of an equation by a common multiple of the denominator. So anytime we have fractions throughout our equation and we want to kind of eliminate fractions as a possibility, we can do it just by multiplying both sides of the equation by the same number, which would be a common multiple of their denominators. Okay? Well, let's take a look at this example in which we're going to use clearing fractions to help us solve it. It also is an example of taking a word problem and write an equation out of it, something you spent some time with in Algebra 1. It says, suppose during the 07-08 regular season NBA game involving the Boston Celtics, Kevin Garnett scored 1/3 of Boston's points in the game. Ray Allen scored 1/4 of the points. The rest of the players scored 60 points. Write an equation to model the situation, then determine how many points Boston scored in this game. Okay. Well, I have highlighted here how many points Boston scored in this game. The reason why I did that is because that's what I'm trying to find, so that's what I'm going to let my variable equal. Okay. So if I let x equal the total points scored in the game, then I can say the total points scored in the game, x, is equal to, well, 1/3 of them were scored by Kevin Garnett. So this is Kevin Garnett's share. 1/4 of them was scored by Ray Allen. So this is Ray Allen's share of the points. And this 60 represents all the other players and what they scored. Okay, so now I have an equation in which I only have one variable x. Well, sometimes it's just not fun to deal with those fractions, so we're going to get rid of those fractions. And if I look at 3 and 4, they have a common multiple of 12, so I'm going to multiply through the whole equation, both sides, by 12. If I do that, I get 12x is equal to 4x plus 3x plus 720. Okay, so now I'm going to go through and do the solving by combining like terms first. So 4x and 3x is 7x. I'm going to get my x's together by subtracting 7x from both sides. That's where I'm getting the 5x equals 720. Now if I want to get x by itself, I need to divide both sides by 5, which is going to give me x is equal to 144. Therefore, that game, they scored 144 points. Okay, the last theorem that we have here is what we call the opposite sum theorem. And it says for all real numbers a and b, the opposite of the quantity a plus b, in other words, negative the quantity a plus b, is equal to negative a plus negative b, okay, or negative a minus b. What that tells us is when you have that negative outside of the parentheses, you need to distribute it to everything inside the parentheses. Here's another example of that, negative the quantity 2x minus 9. I'm going to take the negative 2x and the negative times the minus 9, which gives me plus 9. Okay, so let's use that. We're going to use that in this particular example here. It says, so we're right here, and it says h of y is equal to 13y minus the quantity 26 minus 3y. Okay, so if I'm going to solve that for when the function is equal to 100, I'm going to take h of y out and put 100 in. Okay. At the same time, when I do that, I'm going to distribute this minus to both of these to get rid of those parentheses. And by doing it, I get 13y minus 26 plus 3y. Okay. Now I'm going to combine my y's to get this. I'm going to add 26 to both sides to get 126 is equal to 16y. And then if I divide both sides by 16, I get 63 over 8, or 7.875. So that would be the value of y when h of y is 100.